이걸로 하지 말고 그걸로 할까요? 이게 근데 그 전방향이 나오면 그 편집하기 좋게 나중에
정방향에 여기까지 나오게?
조금 줌을 줄여야 되지 않나요?
네, 줄여.
아 성주도 이 수업 들어?
아, 네. 쌤.
아 쌤도 들어야 돼? 아 듣지 않았니?
석사는 다 들어.
아 박사로 한 번 더. 이게 카메라인가?
예,
어? 이건 큰 거 없어? 이거?
액션캠 그런 겁니다.
응?
근데
응.
큰 카메라가
응.
영상 찍는 데는 안 좋아가지고
이거 우리 거야? 아니면 가져오셨니?
이거 그
어.
학과
아까 거야? 오 이게 잘 보여? 이게 잘 보여? 오 그래? 멀쩡하네.
이게 작은데 영상 찍을 때는 훨씬 잘 나와가지고
이거 그건가? 유튜버들이 들고 다니는 건가? 고프로인가 이거?
그거에 좋은 버전.
고프로?
네.
이건 뭐 얼마냐?
80만 원.
아, 이렇게 아주 비싸진 않네.
네.
근데 이게 해상도가 좋아? 이걸 나중에 이렇게
잘 나오고.
음향은? 이게
마이크가 지금 여기 있는데
근데 괜찮을까?
들어가긴 하더라고요. 저번에 찍었을 때.
아 그래?
그래가지고 그래도 좀 저희도 불안해서 무선 마이크를 좀 해보려고 하고 있습니다.
우리도 그룹 미팅 이걸로 할까? 녹화? 요청을 한 거지?
아, 네.
Okay, let's begin. Good afternoon. So today we have a very special speaker. He's the co-founder and CEO of the company called Blaize. And this company went public this January. I mean, anyone who's interested in founding your own company, you probably know that how difficult it is to make your company going on public, right? So he's a very successful businessman. So the speaker's name is Dinakar Managala. So let me introduce his experience. So he received a bachelor's degree from Osmania University in India, and then he went to United States and got his master's degree from Purdue University. After that, he worked at Intel for 12 years, where he worked on graphic processor, microarchitecture design, and that is used for mobile and graphics engineering group. That's where he worked on. And after that, he co-founded the company Blaize, And the company's goal is provide innovative software and hardware solution to optimize AI for many various applications. So today I believe the talk is not only technical but also his life journey behind making this company what it is today. So let's welcome the speaker with a big hand.
Thank you, Professor, for the introduction. Is it coming through? So first of all, thank you, Professor, for inviting me and this opportunity to present here. KAIST is an esteemed organization, and it's a pleasure to be here and share my experience. It's a room full of young, budding students, and it's very exciting to see all the creativity that can come out of here. Our company is called Blaize. We are a physical AI processor company, processor and software, and we recently went on NASDAQ in January, and with all the work that we're doing in the physical AI and at the core of innovation, semiconductor processor, it's pretty exciting. You know, this is the end. I mean, this is what we IPO'd in January, but what I'm here to actually talk about is all the journey that has gotten us here. As many of you can relate, nothing happens overnight. It did take us about 14 years, 14 long years to get through and you know, get here. Along the way, many interesting stories and twists and turns, broken hard disks, failed parts, so many things, right? All the adventures of fundraising, journeys through customer, etc. Right? Many things that have happened. The one constant thing that remained with us all through our journey is the deep belief that we had that if we work at it and keep going, one day we will succeed, right? And that's what kept us going. So I'm here to talk to you all about not the end result, but more about our journey and everything that we've been through. The hero of our story is definitely our team, our technology, and the belief that has always been constant with us all through ups and downs, and we owe it to them that we're here. My co-founders, Key and Satki, exceptional brains, building processors and graphics chips. Previously, that's what they did, and of course now here at Blaize, what we do is we build chips to provide actions, real-time AI, real-time inference, to provide actionable insights right now and right here. So the chips make sense of the real world, and that's the AI that we bring to smart cities, defense, many other use cases. Let me play a video so that it's more clear what we do in the different use cases.
Cities are evolving, but how do we make them smarter, safer, and more efficient without the complexity? Emerging cities need rapid, cost-effective solutions to modern challenges. Managing traffic, analyzing pedestrian movement, and ensuring safety, all while planning for the future, requires advanced intelligence at the edge. Blaize makes enabling AI at the edge seamless with a unique graph streaming processor and robust software suite, delivering state-of-the-art multimodal analytics right where cities need it most. Identify incidents in real time, from accidents to unauthorized activity. Detect anomalies before they become problems, enhancing public safety. Improve public spaces with pedestrian intelligence, optimizing foot traffic and behavior recognition in places like city streets and retail environments. Plan smarter with real-world, real-time data. Enhance public places like schools, museums, stadiums, airports, or any place where intelligent infrastructure matters most. Unlike costly and complex AI deployments, Blaize's flexible solutions provide best-in-class AI processing at the edge, delivering real-time insights with lower cost and higher efficiency. Smart cities start with smarter solutions. With Blaize, the future is here, faster, smarter, and built to scale.
So those are, as you can see, some of the real-world use cases that are physical AI and that our technology can power. The core of our innovation is a novel processor called a graph streaming processor. Historically, if you see computing, right, there were CPUs and then there were GPUs applied to gaming. Now the world of AI needs a new kind of computing, and that is the processor that we built. It's called a graph streaming processor, doing AI efficiently and in a low latency form and actionable insights, especially in the physical world AI. So the hardware that we build, the chip goes into, just like you have your GPU cards, we build AI cards, and these in turn go into industrial PCs and servers that then get into the market. Now, AI is a very new problem to the world. So you cannot just stop at building the chips and the hardware. There's also software on top that you need to build to make AI very simple to be deployed into real end customer markets. So we actually spent quite a bit of time, many years, building software on top to solutionize AI into practical world use cases, such as the ones which were described in the previous video. So that's our software layer on the right, where we have the combination of Linux-based drivers as well as AI Studio, which is a code-free platform to develop and deploy AI. So the combination of the code-free platform and powerful hardware is effectively like the Macintosh of AI. So that is what we innovated and built in place. The target industries and use cases are very diverse because the solution is completely programmable for our target specific markets. And therefore, what we do is, for different markets, going from left to right, for example, you can see a smart retail solution where you're doing things like inventory management, potentially shoplift prevention. Those kind of use cases are all possible using cameras. Or in a smart city, this could be a very dense server where you have interesting use cases around traffic management, making people's lives safer and secure, and thousands of streams coming back into servers in a data center. Or you can have on a factory floor, right, smart manufacturing, where you have many cameras looking at how do you make worker safety use cases, improving manufacturing, and so on and so forth. It is also used in defense and law enforcement, where you have an entire smart city network with cameras, and how do you actually use real-time intelligence to identify potentially a threat, right, and potentially prevent it. Or simpler use cases where you're doing traffic management, etc., but it's of great value for the citizens. And of course, we also, the longer time horizon, autonomous driving and cars actually needing AI is a key use case that our technology will target. But let's go back to the humble beginnings, right? I grew up in a city called Hyderabad in India. My parents were very hardworking and made sure that education and exposure was a priority. My mom was a science major and she was a gold medalist, and my dad was from the corporate world and primarily sales and marketing and business side of things. So I guess I lucked out in the sense that I got the combined genes. But my curiosity was my teacher. Growing up, I was always into problem solving. How do I solve things, fix things, break things, etc., right? In fact, funny story, my sister and I, we used to actually accidentally break things in the house, and then we used to want to fix it before my parents came back and found out, so that we don't get in trouble. And the thing was that in this one particular instance, we broke a clock and we tried to fix it, and we fixed it completely. But then I had some parts remaining, so they anyways found out, and I got in trouble with them. But all of this was sort of the foundation that I was always interested in problem solving and how do you put ideas to create something, and of course that led later on in the years, how do I apply those same skills to build a new chip, new technology, use new solutions, how do we then commercialize them. I finished my high school and undergrad in India, and then I went to do my master's in Purdue University in Dublin. And once I did that, I went to work for Intel. Intel, of course, was a massive company. At the time, CPUs were all the rage, and the whole Pentium momentum was going on. And Intel was a big company and a great learning for me, right? Where I got to know how chips are built, how they are sold, and it was a massive scale. In fact, the particular team that I was at Intel was building graphics chips. So CPUs took 4 to 5 years to build. The graphics chips actually were much shorter in duration. You had to build it in 18 months. So we were like a small team within the giant Intel. We were like a young company or a startup within Intel, and building chips year on year very frequently. So that in itself was a big learning. How do you actually build something fast? How do you get it to market? How do you serve customers? So that whole experience was a beautiful, very enriching, and a teacher. Although the role that we were playing, me and my co-founders there, was in a certain area, and it has its limitations, right? How much we could influence actually the roadmap and what we could do. And we saw early on that, hey, the kind of compute needs that are required by the more emerging workloads are not going to be satisfied by GPUs alone. So that's when we took the plunge and we said, hey, there needs to be a new kind of a computer for all the emerging problems. And that is how Blaize was born. So this is an early picture from our office as we built the company. I went to a couple of my buddies, my co-founders, and said we were all having comfortable careers at Intel, building chips and so on. We had no investment, no proper plan, and no customers. But I said, look, we have one thing, which is we know how to build complex technology, complex chips, right? And we are capable, and we had that belief. And I said, let's take the plunge, right? And fortunately, they took the plunge along with me. And that ping pong table, by the way, is in our office still. I mean, we moved offices multiple times. The table does go with us wherever we go. It's become part of our history now. Obviously, nowadays we don't get time to play, but it's sitting there, and when we get time, we occasionally play. But my co-founders and I, we took the plunge. At some point, right, there is the balance between comfort and conviction. And at some point, comfort has to give in to conviction. Had we chosen to stay in our comfortable, cushy jobs at where we were, we wouldn't have taken the plunge and done Blaize. So, but we had the belief, and we just had to commit to it. So the single biggest thing was actually committing to it. And committing means you actually take the plunge and say, hey, this is what I'm doing, and just doing it. So we made it happen, and of course, nothing's easy. It took many years after that, but that was our journey. In fact, when we started off, my godparents gave me a small check, initial investment. With that, we built, we got a couple of computers, our laptops, a couple of servers, and we tried to build Blaize. We negotiated free. So in a chip design company, tools are very expensive. So managed to negotiate free tools with our very supportive EDA partner. Even managed to get a free emulation platform. So when you are building a chip, it costs millions of dollars to actually tape out the chip and fabricate it. So before you do that, you mimic the chip on an emulation platform. That platform itself is $1 million+. So we were able to negotiate a free emulation platform. To add to that, we also didn't have money to tape out our first chip. So I had to go negotiate with the foundry to give us a free tape out. So all of this was unheard of, right? And I don't even know how we did it at the time. But as we kept doing one by one, it actually all fell in place and we were able to do that. So the common thing again here is that we had deep belief and made it all happen. I'm a big Korean movie buff and see all kinds of movies and series from Korea. And this is of course one of my favorite. If I had to pick one which kind of depicts our crazy journey over the last several years and how we actually made it, I'd say it's like Squid Game and Jihoon. For a company to build a chip of the complexity that we did, typically at Intels and Nvidias of the world, it takes about hundreds of millions of dollars and anywhere about 4 or 5 years to build something from ground up. And we were able to do this with the initial chip that we built, about 40 people and a fraction of the budget, right? And we still managed to beat GPUs on the performance, on the benchmarks. So what it took is extreme conviction and a team that would never give up, right? And was completely committed. And essentially we were like survivors, right? Going through everything and making sure that we built and made it all happen. So our story is very much a story of the underdog. And here we are, we finally managed to survive all that. So one particular thing I'd like to, right, as many of you may build your own startups, having a good, solid founding team and with complete conviction is extremely, extremely important, because the journey is very rocky, right? Nothing is simple. There are always ups and downs. One particular thing I'd like to, of course, my co-founders are rock stars, right? Each of them. And they're all experts at building processors and software. One of my co-founders, Satiki, excellent at processor design. Val, who is a software architect and algorithms, he's a rock star. And Key, who knows how to put it all together in SoCs and chips and so on. So all exceptional people. I'd like to highlight one in particular, Key. Above and beyond the technology part, right? Many a times in a startup, there are continuously challenges that you get. It can be challenges with regards to team, with regards to technology, with regards to financings, etc. Right? And always these things happen. So it's about how you actually really continue to build during those challenging times. So for example, I remember about 2 years into our company's life, all the venture capitalists were turning us down because those were the days social media and social networking were creating all the financing. Chips were not the thing to fund. They were difficult, capital intensive, and nobody was funding. So we were almost running out of capital. At the same time, I remember all the code that we had written over the last 2 years, the server had crashed, right? So we didn't know how to recover it. So I was on the phone trying to raise capital to keep the company alive, and my co-founder Key was trying to take the hard disks, put them in the freezer, try to revive them, and all real stuff that happened, like a movie almost. And finally we lucked out. The funding came through, the database actually, the hard disks worked, and we got our code back. Another instance is our core expertise is building the processor architecture itself. Then you take the processor and put it in a system on chip. Right? There are other peripheral items on the system on chip. We did not have the expertise, and we did not have the team size either. So one of the days I was looking at, hey, what are you doing, Key? And he said, look, I'm building the SoC. How are you building it? He says, I'm Googling it and building it, right? So he, and I was like, what are you doing, right? I mean, it's a pretty risky proposition. But he actually did it, and the chip actually worked on first boot. So he's that kind of a solid guy, and a treasure to have on your team, right? And he's a solid rock in our entire startup journey. So every startup needs to have somebody like him. One of the key, if you ask me, hey, what's the main pillar, right, or the main culture of your company? I'd say it's the culture of perseverance. We had many ups and downs all through our career, all through our startup life cycle. But the team never gave up, right? The founding team as well as the entire team. We kept at it and kept building, and then eventually success would come. But that is the attitude. So perseverance is a very key pillar. One of my early teachers was my non-profit experience. I used to volunteer at a non-profit that did educational scholarships for underprivileged kids. So I used to do fundraisers. So later on in the years, I learned that this was probably the foundation of all the teachings I had of how to run a business. So when we were trying to plan for events, we needed to make a business plan and make sure that the investment we put in for an event, we recovered about 4x to 10x in terms of funds raised for the organization. The act of getting sponsorships for the event was like a fundraising. So all of these things we did, as well as after the event, right? I cleaned bathrooms and facilities, right, to make sure that it was all clean. So the point is, no task is below you, right? We had that belief, and because of the belief, we had the attitude that we got to do this and make this a success. So when we started up our company, many of these values is what we took there, and you know, the team is of the same attitude, right? Never give up, have the perseverance, believe in what you're doing, and just keep doing it. Right? So these are some of the foundational principles. In fact, one of the times, my board said, hey, I don't even know how you're standing after going through all these things. But the truth is, it's not me alone. It's my team, it's my family behind me. That a lot of sacrifice also goes off into building a startup. For example, in between my business trips, I used to come back and see that my kids are actually growing up a few inches. Right? It's difficult to see that because you missed a certain part of that. But you keep doing that, and then having such a supportive family, right, always rooting for you, and you know, putting up through all of the things that go on, right, and cheering for you, that is immense, and that's one of the key reasons for the success. One of the most important thing about the work that we do, I personally find interesting, is that it touches real people's lives, right? It's we're doing projects like in for example in Turkey, there's an elder care project which involves you know, in elder care homes, identifying potentially somebody falling, alerting the nurse station immediately, or if there are other problems of that nature, right? So the idea is that it actually comes to real value, right? And it's a benefit to the society in a big way. So these kind of projects are very interesting. It could be, how do you make a city safe, applying all AI to traffic and cameras, preventing crime, etc. These are real things that come to life. Applying AI to healthcare, right, for disease prevention, etc. Agriculture, making food productivity more and more. So the common thing, if you see all of here, is these are projects. Of course, it's not necessarily you make the highest dollars in each of the projects, but the projects that we do actually are of real impact, right? And that's the one thing that excites me every day when I wake up and go to work, that our technology that we're building is actually touching people's lives and making an impact. A funny story actually it's not funny, but it's a real story. When COVID happened, we are of course we were an AI company. I got our team together and said, hey, look, how can we help? And at the time, every town and city had X-ray stations, right? And there were no test kits, etc. So the only solution you had was to actually identify somebody with COVID and then and not let them meet other people, right? That was the main thing that we had. So our engineers and data scientists came up with a solution which involved reading X-rays and detecting whether it's COVID or pneumonia or whatever. So we built that technology and then we gave it out to the governments to use it. We didn't want to profit from it, we just gave it out for free. Not knowing, years later, that same technology, a hospital actually approached us saying that we want to commercialize this for X-ray reading for other kinds of lung diseases, right, pneumonia and etc. So and TB and so on. So the point is that what we built for something else, for a good purpose, actually came back around and tried to actually help us commercially. We finally went on NASDAQ early this year, and we're of course proud, we're excited, but the way we look at it is this is a beginning of a new journey, and it's not the end. IPO is certainly good. It gives you a platform to achieve your dreams in the next journey, and our team is certainly excited. But whether it's public or private, the act of building the next generation products, commercializing what you have right now, and building a solid product and so on, that nothing has changed, right? Whether it's public or private, we're at it, right? And continuing to build. So finally, going through all of these ups and downs, right? When we look back and see, hey, especially on a down day, right? Like something's not gone wrong, not gone right, etc. I call this the North Star, right? There's something that is guiding you, that this is why I'm continuing to do what I'm doing. And if I have to summarize it, it's about you set out to do something, right? Your mission, and it's different for different people. For me, it's about I want our technology to be impactful and do good. The second thing was often you come across situations where you don't know the answer, but you just have to figure it out and take one step at a time, and the next step at the next step, and keep doing it. And the third thing is just deep belief, that just keep at it and keep doing, believe in what you're doing, and one day success will come. So this is, for me, my North Star, and I continue to execute and do it this way. For all the brilliant minds here today, right, KAIST students, I think all of you are exceptional, that's why you're here. And there's no time like today. AI happening, as well as I've seen YouTube videos where people are building the kind of websites like LinkedIn, etc., right, which used to take years and hundreds of millions of dollars. In a minute, they're able to build that, right? So it's an exceptional time for young entrepreneurs to go off and do something. If you have an idea, of course, believe and just commit and do it, right? And all the AI tools, etc., are all there to make it all happen. So it's an exciting time, and I wish you all the very best. With that, I'd like to thank you for the opportunity and open it up for any questions.
Thank you very much. Very inspiring talk. So let's ask him some questions. Yeah, they tend to be shy, so maybe I should. Oh, there's one.
So what exactly is the advantage of the graphics with GSR, was it, over like GPUs?
Sure.
Yeah.
So AI applications, right? As much as compute demand is there, there's also memory bottleneck, right? They're very memory intensive. So the way that GPUs were built essentially for a different problem, which is gaming and graphics, and they're being retrofitted for AI. What we built is a processor architecture that understands these complex AI workloads such as data flow graphs and does them in a more efficient manner, in a faster way, but also we remove the memory, we reduce the memory needs because of the streaming approach that we did. It's one of our patented secret sauce. And the net benefit to the end customer is they realize AI in a smaller cost and power envelope, right? But the foundation is how you actually run these algorithms. Just like GPUs do something known as data parallelism, we do something known as task level parallelism, where in AI there are many tasks, you're able to concurrently run them, therefore faster.
So Google and like Nvidia has their own in-house chips now. So also Google has also working on multiple applications like self-driving cars and stuff. So how is your product different from what they do? Like, in terms of
So, good question. Google and majority of the cloud providers, they're building their chips mainly targeting the cloud applications, right, and data centers. And deep data center, there's Nvidia, there's them, and of course there's fierce competition. We consciously chose to focus on the physical AI, right, outside the deep data center. It could be edge of the cloud, it could be in devices, etc., etc. And the specialty of our chip again is the patented secret sauce that we have, and making it completely programmable. So often these cloud providers, when they build a certain chip, they're targeting their own proprietary workload, right? And they're very good at that. But if you have to build something which is truly versatile for a diverse set of use cases, you need full programmability and being able to do it for these. So that's our specialty. And then how do you actually build a software on top of it so that it's easy to use, right? That's the other part of the innovation. So that's how we look at it.
so that's open source, right?
We conform to open source, and we have, of course, our drivers and compilers which are owned, but they fit into the open source ecosystem.
Thank you.
We partner with third-party software application companies, right? Like for example, for a smart city application, we'll have partner X running on our hardware and software. For retail, another partner. For defense, another partner. So building out complete solutions for each one with partners.
Thank you.
So I have a couple of questions. So the Nvidia, I mean, when they began their business, I mean, they probably wouldn't expect they would this big. And so you spent 12 years at Intel working on graphic GPU. Then why didn't Intel seize the moment like Nvidia did? Because they apparently had a division working on the GPU. So what's the difference between Nvidia and Intel? Why one became so successful and the other didn't capitalize the weight?
Sure. No, good question. So the first thing I guess is Intel and Nvidia, as far as graphics goes, pure shipments of volume, Intel actually is quite successful in the sense that they integrated, the strategy was always, Intel's strategy was selling CPUs and more CPUs. And so they integrated graphics into the CPU. And every laptop that you have, right, a MacBook or so-and-so has a CPU and graphics integrated. So when you need just enough graphics to run the operating system to do your daily tasks, that is sufficient, and that ships immensely in huge volumes, right? So it's very successful. Now within graphics, I think maybe one of the questions you didn't ask, but it's like this. Just like Nvidia and Intel, there's of course another company called ATI, which became AMD now.
Yes.
So in the world of graphics, there were about 40 odd companies at the time, and only 3 succeeded, others failed. The reason is these 3 bet on programmability, and gaming and APIs came in, and all these 3 companies bet on programmability and they succeeded. The fixed functions, which built on dedicated accelerators for something, they died. So in that sense, Intel's success, as in the graphics survived, etc. The second part of the question, maybe what you're trying to ask is, hey, how did NVIDIA go on such a big tear? The answer is, of course, they invested heavily in the CUDA ecosystem, which they were early to the party, right? And they had CUDA for years. Of course, NVIDIA very visionary and smart, and they invested in CUDA, trying to promote it in all kinds of places, scientific research, university, etc., etc. Fortunately, AI, one of the big growth drivers, met CUDA, and of course, rest is history. So these were some of the reasons, and having that emphasis on programmable but accelerated computing, right? That was the big vision. While Intel, of course, stayed focused on CPUs mostly, right? That was one distinction. You had
My
another one.
second question is, you briefly talked about up and down, how you leading the company what it is today. So what was the hardest moment? I mean, you talked about the server freeze and then capital was low and you were making phone calls and etc. But was that the most difficult time, or there were other times that were even more difficult that almost made you maybe give up?
So, to be honest, there were many difficult moments, and it happened through there was that, there was our chip came back, and then COVID was hit. Suddenly, we were trying to actually sample chips, and where do we send them because customers are shut. There were many hardships along the way. There's no one easy one. I mean, and it continues. I think the challenges continue. But the way we do it is we just look at it and, of course, say, hey, how do we find a solution to it? And fortunately, the team is stellar, right? And we look at it and we try to solve it and move on. But to answer your question, there are many hard moments along the journey.
What is the most memorable?
Oh,
is that the one with the frozen server? And
I think running out of capital is certainly the most, in a startup entrepreneur's life, I think running out of capital is a very significant one. So those, we had some of those incidents early in our career, those were difficult. Yeah, I think that was the main thing, I would say, those instances.
Okay. Thank you. Any other question? Yeah, if not, let's thank our speaker again.